Hi, we are engineering brothers, and this is our last problem for our translational system, additional problem 4. And I should read out first. That will be much more better for you to understand our problem in a lot more constructive way. So here a diagram is been given, and what do that mean, the value for our Q1 F B2 that is been indicated over here. So first I should read out first. Consider the following mechanical translation system. So this is our mechanical translation system that has been given over here. F denotes force. So the force is applied on our mass block of M1, and because of that applied force, the frictional force of V1 that has been present in between our surface and the wheel for this mass block of M1, and rest of the parts for our B2, K1, M2, K2, B3 that has been present in our given consideration. X denotes the displacement. So you can see that because of that applied force, we have got the block do have the displacement of x1t, and because of that displacement, the adjacent block of M2 has also got the displacement of x2t over here. So x actually denoting our displacement, M denotes mass. So we have got two mass blocks that are M1 and M2. So you can see that M denotes mass, B denotes friction. So you can see that we have got three friction elements over here. One is been present in between our wheel and the solid surface for our mass block of B1. Similarly, for our M2 block also, the friction in between our wheel and the solid surface is quite naturally the B3. And at the intermediate or at the middle part in between of our two blocks of M1 and M2, if you say our rope is being utilized to adjust or to have the connection in between this M1 and M2, we can see that there is some certain amount of friction that is been present in between our two blocks of M1 and M2, and that frictional force or that friction coefficient is been indicated as our B2, and the K denotes the spring constant. So we have got the two spring constant which are indicated as K1 and K2 over here, and the K2 is directly attached with our solid surface or that has been directly attached at the wall. So this is our wall. You can see that the K2 is been directly attached at the wall, and the K1 is been present in between our two mass block of M1 and M2 over here, and so this is quite naturally the K1. So K denotes the spring constant. Write down the differential equation governing the above system. So first we should come out with our differential equation, and then we should apply the much needed consideration or much needed way to have the best form of transfer function over here. So first I will do have the ratio for our transfer function of x2s divided by fs, and for the second part we do require to find out the next transfer function, which is x1s by fs. So this is our problem statement over here. In our previous steps we have described our how to have the problems that do require to solve, and what are the important steps that I am just going to show you over here. In our previous step I have already given you that if you do apply the force, the block do get disturbed by that applied force, and after that it will do transfer to the adjacent part for our blocks over there, and because of that consideration we do require to find out the differential equation, or quite specifically differential governing equations for this set of systems over here. So before I go into that one, I do require to follow some important steps over here. So the first step will be quite naturally the much needed consideration for our nodal diagram. We need to convert this diagram into nodal diagram. Nodal diagram. That will be better for us to have the best flow analogy, and we can do apply the much needed consideration for that one over there. And for our second step we do require to apply the D'Alembert principle. D'Alembert principle to have the much needed differential governing equations over there. So we do require to consider the D'Alembert principle on both our displacement factors of our x1 and x2t over there. Next one will be we do apply the Laplace transform on that much needed consideration for D'Alembert principles over there. So the next step will be to apply our Laplace transform. The Laplace transformed way, or to apply the Laplace transform on the D'Alembert principle, differential governing equations over there. And after we do apply the Laplace transform over there, then we do require to consider or configure the much needed consideration for our much needed transfer function over here. So the first step will be x2s by fs. That is our much needed steps that we do require to follow over here. So at first we do require to convert our much needed given mechanical translational system into a nodal diagram over there. And how to convert that, let us do show you in our next upcoming steps that are very, very essential over here. So that one will be our first step, which is just to convert this conventional translational system into our much needed nodal diagram over there. And in our second step, we do apply the D'Alembert principle on our both displacement part for our x1t, x2t over there. And after we do apply the D'Alembert principle, what is the D'Alembert principle? If you do apply the force on any given body, the applied force plus resistive force, the summation of these two different set of forces and opposing forces. Why opposing? If you do apply the applied force on this given hand, so these hand also prevent this applied force. So if you do apply the force in this direction, the resistive force will be in direction or in this direction, the opposite direction with our applied force. So first I should give you the much needed example that will be much more better for you to digest up to this one. If you do apply the force, say this is our given body, if you do apply the force in this direction, so quite naturally the hands do require to stop that applied force over there, and because of that the applied force plus resistive force. So if you do consider these two opposing force, then the summation of these two forces will become zero. That is the D'Alembert principle over here, and because of that zero resultant force on that D'Alembert principle, or according to that D'Alembert principle, the body will stay at the equilibrium position over there. So that is the D'Alembert principle over there. And for our next part, after we do have got the two differential equations over there, the next step will be, if you do apply the Laplace transform on that given D'Alembert principles equations over there, we have got the Laplace transform equation over there, and quite frankly we do have converted the time domain equation into a Laplace domain transformations over there just by applying our Laplace transform over there. And at the last stage we do require to form the much needed ratio, which is our x2s divided by fs. That one will be our first transfer function over here. So these are our important steps that we do require to reflect over here. And these type of steps are very, very essential for this type of consideration over here. So first I should start with our nodal diagram over here, and then we do require to apply the D'Alembert principle on our given displacement blocks of x1 to x1t, x2t over there. And in our next step we do apply the Laplace transform on that given governing equations or given differential equations that we have got from this translational system over there. After we have applied the Laplace transform, we need to form this ratio which is x2s divided by fs, which actually give us the much needed consideration for our transfer function, which one is our first consideration, say x2s by fs. So these are our important steps that we do require to follow over here. And so let us start our consideration over there. So our first step is the nodal diagram. So what is the important way, or what is the important steps or objectives to try to draw the nodal diagram over here? So let us show you over here. So first we do consider our two displacement parts over here. So the first one is our x1t. Say the x1t is being present at the left hand side. And you can see that for our given translational system also, the x1t is present at the left hand side for our diagram. So this one is our x1t, and at the right hand side we do have the x2t over here. So this is our x2t. So in our next step, we do require to do connect our much needed diagrams or block diagrams over here. With our x1t, I can see that the mass block of M1 is being present over here. So with the x1t, that is directly attached with our M1. Why? Because if you do apply the force on the given mass block, the mass block do have the displacement of x1t. So the M1 is directly connected with our x1t. So this is our M1 that is being connected over here. So this is our M1. In our next part, we do require to have that concentration or consideration that there is some friction coefficient that is being present, which is being named as B1, that is being present in between our wheel and the solid surface over there. So let us do include the B1 as well. So you can see we do require to include our B1 over here. So this is our B1 that is being considered as our dashpot system over there. Okay, and let us say that in between our this x1t, x2t, the B2 and K1 is being present over here. So once again, in between our x1t, x2t, the B2 and K1 that has been present in between these two displacement parts over here. So without wasting any time, let us do include over here. So this one should be our B2, that is our another dashpot setup that has been present in between our two displacement factors of x1t, x2t over here. And let us do include our spring of K1 that has been attached in between our x1t, x2t over here. So once again, we do require to include our spring over here. So this is our spring setup, and this one is quite naturally our Q1. Okay, and once again, let us do have the consideration for our x2t as well. So for our x2t, that is directly attached with our M2. So without wasting any time, let us do include our M2 over here. So this is our M2. And our B3 that is being once again present over here. So this is our B3 that is being directly associated over here. So this is our B3. And the K2 that is being attached over here. So this is our K2. Once again, we do require to include our K2 over here. So this is our K2. So this is our K2, M2, B3. K2, M2, B3 that is directly associated or connected with our x2t over here. That is why I have connected the x2t in between our x2 and x1t. We do have the consideration for our B2 and K1 over here that I have already reflected over here, and the mass block M1 that is been associated with our x1t, and the applied force that will be associated over here, and the applied force, this is our applied force. Okay, and this is our F over here. So this is the complete picture for our nodal diagram. So I do require to repeat this portion once again. First, you do require to identify which element do have the direct connection with our displacement factors of our x1t, x2t over there. So first I have separately considered our nodes of our x1t, x2t over here, and let us do identify which elements do require or do connect with our x1t elements over here. So you can see that with our x1t the M1 is being directly associated over here. That is why I have included the M1. In between and at the position in between our wheel and the solid surface, we do require, we do have the frictional coefficient of B1 that has been present over here. That is why I have directly connected B1 with our x1t over here, because you can see that this block is directly associated with our x1t and the B1 that has been present over here. So let us move on towards our right hand side for our block diagram. In between our x1t, x2t, we do have the two important elements of dashboard and the spring system that has been present in between our x1t, x2t over there. And without wasting any time, we have included the same or that one or that diagram is being included over here. So we do have to include our B2 and K1 elements in between our x1t, x2t over here. As you can see that these two blocks do have the displacement of x1t, x2t, and in between this x1t, x2t, the B2 and K1 that is being present in between our x1t, x2t over there. That is why I have included these two elements over here. Now move on towards our last part, which is our x2t. With our x2t, you can see that the mass block of N2, B3 and the K2 that are directly connected or associated with our displacement of x2t. So with our x2t, we do have to add our B3, that is B3, and then K2, this is our K2, and the mass block of M2 that has been present over here. And at the extreme hand side over here, we have applied the force on this block of M1. Because of that applied force, we do have the disturbance for our overall setups over here. So we do require to include the force at the displacement block of our x1t, because you can see that this block is being directly associated with our x1t over here.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates and stay tuned to the channel. Thank you and goodbye.